Good morning, and once again, welcome and thank you for attending today's event. I'm Michael Warren. I'm Vice President, North American Sales for Pasqal. It's my 7th year in quantum, but before I got into quantum, it seems like a long time, doesn't it? I spent a career at Intel Corporation, and during my time at Intel, I drove global innovation projects at major pharmaceutical companies. And what that really meant was taking new and novel technologies and taking them from the R&D lab into production environments and creating business value. So if you go way back, think about things like virtualization, cloud computing, software-defined networking, big data, the list goes on and on. They all started as very new, novel concepts, and now very mainstream and driving hundreds of billions of dollars in the marketplace. I feel quantum is in that spot right now at a level of maturity where we're seeing things move away from science projects into creating business value. So I'm excited to see what this will do for the industry and especially the energy sector. So we have a great panel today. I'll let them all introduce themselves. Dr. Wang, if you'd like to start off.
Hello. Yeah, my name is Qinhua Wang. I'm a product manager for reservoir management technologies at Halliburton. And my primary responsibility is to leverage native technology like HPC and AI to help customer to optimize reservoir production and maximize asset value. Before this management role, I was a research scientist at Halliburton, focused on reservoir simulation, primarily HPC, right? So basically, before that, I was my PhD and postdoc, again focused on HPC, but it's for direct numerical method for turbulent flow, like coal or gas oil combustion. Thank you.
I'm Worley, founder and CEO of Strangeworks. We are a quantum computing software platform that provides heterogeneous capabilities, so you can mix in all the GPUs and TPUs you want. And we're really focused on eliminating the barriers to using the quantum, so lowering the cost barrier, lowering the technical barriers, and really making it where a bunch of people can consume this. If you think about it, one of the problems we face as an industry is if you have to have a physicist or a scientist involved in using the product, we've reduced the total addressable market by people to like 0.1% or less of the population. So getting this in the hands of subject matter experts and other people who don't have that quantum knowledge, maybe even aren't software developers, is really important. So to that effect, I've co-authored 2 books, Quantum Computing for Babies, which is a literal cardboard book, although someone sent it to the American physicist something for a peer review, which I thought was ridiculous, and Quantum Computing for Dummies. And we basically try to go and just get people really excited about it and really involved, and then provide a platform that makes it very easy for enterprises to consume this technology.
I need to get that book.
And hello, I'm Larry Bowden. I'm currently at Woodside. I recently left Chevron as a innovation research scientist of a few years, and now I'm an analytics lead. So I'm in the quantum unmeasured state, unable to speak for either company, but I'm actually very happy to share my personal experiences in quantum. At Chevron, I designed and implemented the first production systems that use quantum computing for analytical chemistry applications in designing and synthesizing catalysts.
And I'm Peter Lemke. I started with BP as a drilling engineer, and along the way worked as a data analyst. I've been working with nascent technology since about 2017. So I think, Worley, we met in 2018. Done a lot in the quantum space. That's not something that's widely known, I don't think. BP is quite quiet about it, but actually done a lot of work with the various companies on this panel. Clearly, Halliburton, Strangeworks have been working for at least the last year or so. What I bring to the conversation is an awareness of how operations actually happen and how decisions are actually made with the outputs of compute. So I see it from that angle, and I hope to bring a lot of that to this conversation.
Thank you. So I'd like to get things kicked off. I think we're seeing an undeniable trend in the marketplace now where people are moving away and organizations are moving away from purely doing scientific experiments and moving into the business realm. How do I create business value? How do I make money with quantum? How do I satisfy a line of business manager or the C-suite into investing in quantum? And one of the questions I've gotten after attending literally hundreds of business meetings is how do I get ready for quantum? What does quantum ready mean? And there are many topics, how do I get smart on quantum? So there's an education component. Do I hire a quantum scientist? Do I outsource to a consulting firm? What sort of IT governance issues am I going to get into? Data management issues, legal issues? Do I do non-competitive collaborations? And there's a whole host of things. My point here is I get a different answer every time I ask the question. So what I'd like to ask the panel there we go. Thank you. What trajectory does it look like at your company to become quantum ready? And Peter, would you like to kick off and start that one?
Yeah, you actually hit quite a few of them because having come to a lot of these conferences over the years, the thing that strikes me is in 2017, the whole space was dominated by like very academic, a certain amount of startup energy, and like ventures mindsets. And in the past year going to conferences, what I've noticed is the people who are showing up and speaking are defense, government, oil and gas. And that's sort of like this, I don't know, canary in the coal mine that tells you that this stuff's starting to get much more serious, that these kind of players are starting to talk about their level of quantum readiness. The thing that hasn't changed just yet in terms of getting ready for quantum readiness is we're still talking about quantum adoption will happen when we hit some sort of peak moment of like error correction, or like it's going to have to solve a certain size of intractable problem. And when that happens, now all of a sudden you're going to get this sort of like massive shift in the industry. But what actually affects the adoption, where quantum readiness really happens, is like model assurance. If I'm going to use quantum to do like a portfolio calculation, there's a lot of governance around the models I'm actually allowed to use for my portfolios for trading. And so when the government accepts those new kinds of models is when you'll start seeing the adoption. The other thing is there's a lot of quantum readiness that's around what happens after you have your answer, which I don't want to dominate the conversation too much on that, but I'll probably come back to it in one of these future conversations or questions. But just as an anecdote to that, when I made the switch from drilling engineer to data analyst, I started being in the rooms for not just my decisions, but like supporting other bigger decisions. And I'll never forget this moment when a slide came up and it had a few bullet points, and those bullet points were the summary of a massive amount of computation. So probably the single biggest consumer of upstream computation is seismic data processing in oil and gas. And it takes weeks and weeks and like millions of dollars of computation to create these models. And all of that modeling came down to a few bullet points that were part of a much broader discussion, and very little conversation had around that. So quantum readiness is not going to be about when can we actually solve the intractable problem. Yeah? It's a much bigger decision, and that's a big part of what I get involved in.
Thank you. Dr. Wang, what's your experience been at Halliburton?
For quantum computing, right? For us, for me, I mean, for myself, is kind of a buzzword years ago. And then we invited some technical, organized some technical session. I think years ago, invited one of the speakers come to our office. So basically, we look at two technical team, right? Can take advantage of quantum computing. One is seismic processing. The other one is my team, reservoir simulation. Because reservoir simulation is really a computer demanding area, right? So we need a lot of computer power. So we look at, but the more I look into, right, read the paper, I think an interesting thing is quantum computing has a lot of potential, okay? especially today, this morning's presentation is talk about the linear algebra, right? Can deliver exponential speed up, exponential. Okay, that's great. So so we think how to integrate this to our existing software stack, right? Right. So the problem is on the paper, right? We'll talk about exponential speed up is based on the bigger computer, okay? Not a small computer. I'll talk about 100,000 qubits, not just 10 or 100 qubits. So they're not achievable. And the second factor we look at is for engineering application, right? Fast. For ENP industry, accuracy is very important. So the solution come out from your software must be accurate, okay? Must be accurate. So how to define the accuracy? We'll do hazard matching, and then you have some basic results, whether they're based none. Basic results most common from some hazard match results based on CPU run results, okay, CPU or some HPC cluster. So the problem is, if we want to adopt quantum computing, we need to make the results come out from quantum computing must match those we get from the HPC cluster. We'll talk about the baseline results. So, but given the nature of quantum computing, is this accuracy is guaranteed? So that's the problem. Because the same like we did GPU adoption, right? We found some issues. Because we do the atomic action in GPU, we found the results shifted. So we don't, it's really interesting, right? So we spend a lot of time to adjust the algorithms to make the engineering results match the baseline, okay? That's very important. The third factor I think limit very important is consistency. I think many people ignore this factor. Actually, it's very important in engineering application. Is every time just assume, right? You have a system, no matter it's GPU or CPU or quantum computing, you have the same input. The results supposed to be identical, no matter how many times you run, right? So my question for community is for quantum computing, can we guarantee with same input, the results come out from the quantum computing will be same, identical, consistently, okay? So the three factors, right? Performance, scale, right? Scale, performance, accuracy, consistency, limit the adoption of quantum computing. Yeah, that's my understanding.
Thank you. Larry?
Yeah, I think most companies are quantum ready. Let me share an anecdote to explain this. So as part of working in a research innovation team, we had a POC to build a quantum algorithm to do something useful. That something useful was calculating some thermodynamic properties more accurately than conventional computing. So it wasn't a question of speed or anything. It was just purely accuracy. And our end users team said, hey, this is useful. We'd like to incorporate it into our lab notebooks as a calculation point. How do we do it? Oh, let me just create an API endpoint for you, and I'll deploy it on the Chevron uses the Microsoft Azure cloud. Let me deploy it on the Azure cloud. And here you go. All right, who's going to support it? And this is where things got dicey. All right, no one could support it. I went to our machine learning engineers and said, no, we don't know anything about this. Look, I tell you, it's easy. Give me someone, let me mentor them. I will support it until we can transition. And it only took 6 months to take someone, a machine learning engineer, with no quantum experience, no quantum knowledge, to get them to support a quantum production system. So I think what companies need is a good quantum engineer for mentorship and start upskilling their workforce as use cases come up.
Thank you. Worley, not in the energy industry, but in the quantum industry, and I think you hold the world record for attending the number of business meetings in quantum. So when you get asked that question, quantum ready, or what does the glide path look like? What is your standard answer, and what advice could you give to companies getting into quantum for the first time?
Yeah, I think when I think about it, you know, and these are all great points that the panel's making. I think about it from my days at BMC and Tivoli and some of these enterprise system management companies. And what does it take for enterprise to adopt it? You know, and Peter's like, look, the policies and what you're doing and how it's driving into the organization matters a lot. And the mentorship's a very good point, and your points are excellent, right? You want repeatable answers and everything. But I think the thing that confuses the industry most is the industry itself. right? We are our own worst enemy in that there's a lot of competing thoughts of this modality or that modality. I love that Pasqal has a hybrid approach and is doing the deal with IBM and all of this is, I want to see more of that. Because if I'm a CIO, I'm looking for better, faster, cheaper, always. It doesn't matter. And so if your solution is 1,000,000 times as fast, but it costs 1,000 times as much, I'm not using it, right? Good enough works, unfortunately, in a lot of these things because of a lot of things we're talking about up here. But I'm seeing a big shift in that. 2018, not a lot of companies interested. 2020, kind of see a little bit of an uptick. Now you come to 2024, and what I'm seeing is that, necessity is the mother of invention, but it's also the driver of adoption. And so if you look at the energy industry specifically, we use 604 exajoules of energy in 2022. In 2023, that had gone up to 620. And you think about all of the talk we're hearing about the AI and all of the processing and energy power it takes. And yes, it'll get cheaper over time and the processors will use less energy and all of this. And you start thinking, wow, like quantum as an alternative, quantum as a solution starts to really shine. It starts to really become something that people are looking at. And so I'm seeing that, there's still this timidness on the part of a lot of enterprises because unfortunately, in 30 years of enterprise software, nobody loves to be the first, right? And so there's still this hesitation. And the problem is with quantum, you can't afford to not be working on it. A lot of people, and a lot more people than you think. I mean, Peter just said, been working on it, don't talk about it a lot. I know 6 of you in the audience who are doing the same thing. I think we need to have a little bit more talk, a little bit more sharing of those success points. You talked about co-opetition, right, which I like to call it. So it's like maybe they're kind of competitive, but you're going to work together anyway. There's plenty of room for energy companies to work together, for energy companies to work with more quantum companies or a diverse set to really drive that. But we have to deliver to enterprise what they need. I think 2024, you're seeing quantum computing do that. The prices are coming into range. The technology is coming to reproducible results that people can count on. So I think 2025, 2026, I'm looking at these as being really big years for uptick, especially in defense and energy and pharmaceuticals.
Thank you. I'd like to stick with the theme of value creation. And another question I always get, and I know you get, is when will quantum computing be a thing? And the stock answer is no matter when you ask the question, no, 2 to 3 years from now, which always amuses me, having been in it 7 years now. But what I'd like to ask, specifically about the energy industry, what use cases, if solvable in the near term, and we'll define near term as the next 3 to 4 years, what does that mean for upstream, downstream, supply chain optimization? Where is that ROI coming from? And when will that become a earnings per share impact for your companies? Yeah, Dr. Wang, do you want to start out with that one?
Sorry. So 2 areas, right? I think I have some thought about is first one, we'll talk about the high performance computing, pretty much integrated approach. I mean, hybrid approach, right? So basically, this QC will work as the accelerator, like pretty much what the GPU has done for the current high performance system, right? This is one area. The other area is but I don't know how much value can bring to the table, right? Is the large language model. That's what we have done. Fine-tuning some large language model with to fit some particularly domain application, right? So the tuning currently take about, again, on NVIDIA GPUs, current data size about 40 GB or 50 GB takes 2 days training. So I don't know if in the future, again, it's fine-tune. We just train based on pre-trained Meta Llama model, right, with our own training data. So that's a fine-tune take 2 days. So if we increase the data, right, the data size, just imagine, right, if double the size to increase more data, the training time will be increased exponentially. Okay, I talk about maybe weeks. So I don't know if QC can play a role here. I'm not sure. For example, your cut the fine-tune time from weeks to just 1 day or 2. That'll be great.
Peter?
Yeah, so we're thinking about that a little differently, perhaps, from the question, but the spirit of the question is there. If I narrow it to types of optimization problems. It's not really about, is it better in, say, midstream, upstream, or downstream? Because those optimization problems can be understood as a mixed integer program. And so the way we're seeing that question is more, what are the constraint types in a mixed integer program that can scale best? And then once I have that answer, I can re-pretend my business problem into that constraint type. Yeah? So I would answer that with any kind of mixed integer program that can scale well on the hardware that I already have today in a hybrid context. So if I can break the problem up and send some pieces of it to more nascent technology and get a better result, not faster, and let me clarify that in a second. I can get a better result than I would get with just classical computing. That's actually really helpful. Because what I alluded to in the beginning, where I've seen massive computations where like the result of the computation is just a bullet point in a big decision. A lot of the real, as an energy company, if we're making decisions that depend on big calculations, we need information about the information. Yeah? We don't just want a result. It's not good enough to just say, I can solve my traveling salesman problem 1/3 of 1% better if I do it this way. It's, I have a family of robustified solutions and a sensitivity analysis around each one. And I have some additional context around that sensitivity. And I can tell you, if I build an operating model around this family of solutions, I actually have an extremely resilient operation. Yeah? And that's going to be true whether it's midstream, upstream, or downstream.
Thanks. Worley, what are your thoughts there?
I mean, I agree with Peter. No, good. Look, I think that there's a ton of areas, but I think, this hybrid approach that we're all talking about is definitely the key. I mean, you take something like Shor's algorithm, right? There's like 5 steps. Is it even or odd number? Is it factor 2 coprimes? On. Only that 4th step do I need a quantum computer from. So I think, breaking things down into first principles and deploying them across a heterogeneous infrastructure is clearly going to be the way of the future, and clearly going to be the glide path for companies in the energy industry. I mean, you're using the resources you already have. One thing we see with all our energy involvement, all of our customers, the labs work with everything, is what Peter said. I think it needs to be restated, which is they don't just want an answer. They need to know the information about the answer. They have to have an understanding. They need a lot more than hey, it did it. And when you start taking that and you say, okay, the costs are coming down, you're starting to see quantum work in this heterogeneous way, you're going to see these adoption cycles drive up significantly. And we're already seeing that.
Larry?
Yeah, I'm going to answer this question very differently. And part of it is because of where we are in Houston in this energy transition. I really think the power of quantum will enable the energy transition in different ways. So to directly answer the question, where are the opportunities in oil and gas? With unconventional wells, we inject chemicals to enhance oil recovery, where otherwise oil would remain trapped in their voids, and such things with shale. With quantum, there are ways to create algorithms to model these chemical reactions that more efficiently account for quantum effects in very small pore spaces. And these improved first principle thermodynamic calculations will enable better chemical formulations for unconventional wells to perform better. And that moves the needle for oil and gas companies that have unconventional wells. That includes BP, Chevron, Oxy, most of them, particularly due to our locations in Texas and New Mexico. The other areas where it's going to greatly help is in catalyst design and synthesis. Right? Why do we get oil out of the ground? Because we send it to refineries to create cool things. Well, that has a carbon footprint that creates energy. With improved catalyst, you can reduce and improve these things and even have the potential of creating new kinds of supply chains. And to understand that, then we get into optimization. And I really like the idea of using quantum graphs. By modeling logistics with graphs, going from point A to point B, it's not a straight line. So conventional graphs don't solve the problem that you're trying to ask, what's the most efficient way to go from point A to point B? But a quantum line integral from the points in the quantum graphs will answer that question and will offer a quantum advantage.
Great. Thank you. Last question here. So given the introduction of generative AI in the last year or so, what does the intersection of quantum AI or generative AI and quantum look like for the energy sector? Do you see latching on to a generative AI project to accelerate your own quantum efforts? Peter, why don't you start things off?
Yeah, I actually saw my name on a prior slide for some stuff that we've done that's at that intersection. The short answer is yes, there is a combination of the two, with the caveat that a challenge for a company like BP to adopt something like generative AI is having a good answer isn't enough if I have to defend that answer to regulatory bodies and I have no explainability. Yeah? So if I'm like, so let's say I find a new material using a combination of quantum and generative AI. I still have to actually defend that new material's physical properties using a lot of classical techniques because those classical techniques are embedded in the regulation. So again, it's like there's the adoption, but then there's a whole nother aspect that is what I consider to be quantum readiness. You know, I don't see quantum readiness as do I have the right quantum algorithmist working in my company? That is a part of it. But that's honestly not as hard to solve as getting a regulatory body willing to adopt a different model. Yeah? That's going to be your big barrier.
Worley?
Well, I mean, for years I've been talking about quantum and AI and being symbiotic technologies, right? In one, we're trying to take nature to compute. In the other, we're trying to like duplicate a brain, which is made by nature. I have to have a caveat. We recently were selected as one of 3 of Amazon's Gen AI partners, and the only quantum Gen AI partner for the energy industry. So it's kind of like, yeah, we love this. We just in July in Tokyo introduced StrangeWorks Workflows, which is effectively allowing you to use any of the AIs you want, so Llama, Claude, whatever, to effectively talk down through conversational compute to the quantum infrastructure. And so we do the discovery and the problem formulation. All of that is now automated on top of the platform by Gen AI. And that includes things like, what machines do I deploy it to? Which is a question we get from customers a lot. It's like, okay, I've made it. This is my problem. I formulated it. How do I get it off to all of these machines? And a lot of that, especially based on 8 years of gathering data of millions of operations, we have what we call a tiny language model to lay on top of that, and then industry-specific models, which you mentioned, which is exactly what we're doing, because whether it's aircraft loading or energy or whatever, an answer that's 10001 doesn't mean anything to a subject matter expert, right? And so not only does it need the evidence that Peter mentioned, but it also needs to be able to say, okay, I've got something that I can understand and deploy. And right now, with the level of experimentation from enterprise and quantums, they want to do this over and over and more and more. And so Gen AI plays a really great role. Like, look, it's not going to discover the next great quantum algorithm. It can help somebody who has no quantum knowledge or no program knowledge that's a scientist to come up with a formulation, deploy that formulation, and get their answer back, and kind of expedite them going through those levels of that process.
Dr. Wang?
I think we have experience, as moments ago I mentioned about integrating large language model to our cloud offering. So basically, right, for that is Gen AI. I think it's very interesting, right? So basically, we use as I mentioned moments ago, we use Meta Llama, right? Training with our own data, and then use this large language model to help customer to generate results. Report and analyze results is very helpful. I think it's a must-have for pretty much for all the cloud-based product for ENP industry. Second one is because I'm manager, right? Manage a team. That is Microsoft Copilot. Is a lot of code gen, right? I think that is pretty much all the developers these days use this Copilot to help them develop new code, right? Own code, right? It's kind of again, right? It's kind of is lesser for pretty much for all the developers. The third one, I don't know if this is not Gen AI. It's not a part Gen AI, but it's machine learning. I think quantum computing maybe play a role here. Is one area, right, in machine learning for physical simulation, right? So basically, we look at the limit, right, for physics-based simulation is the equation, right, is always approximation to a physical process. So always some introduces error there, right? So basically not accurate. So this is some new class way to do simulation. It's machine learning based simulation. For example, result simulation. We have the physical informed neural network. It's combined data, all kind of data, right, with your physical based equations, right? Then you require a lot of computer power. So just imagine, right, give the layer of the neural network and the nodes for each layer, lot of computer power required. So I'm wondering if QC can play big role in this area, which is going to replace or at least a big extension for the physical only based result simulation or safety. I think there was one of my colleagues show up for so. There's a computation, right? It's data driven and a physical informed simulation, right? So the downside is where the computer power come from. So maybe quantum computing maybe somehow can play a role in here for machine learning based physical whatever simulation, right?
And Larry, we'll wrap it up with you.
Wonderful. So while I agree with everyone, I want to expand a bit. Just as LLMs have given rise to prompt engineering, Gen AI has given rise to something called synthesis engineering. And what that enables is companies to start storing their knowledge in different things, like vector databases can make things searchable. But when people start making their use cases searchable, their code base to solve use cases searchable, their pipelines, machine learning pipelines searchable, and everything else that goes into it, LLMs are really good at transformations, and it will be conceivable for to enable the capabilities or abilities for companies or organizations to create new workflows and new processes with quantum components to answer questions more cost effectively and quickly. So that's something to watch out for, and I think it will happen.
Thank you. I think that'll about do it for the time. I'd like to thank the panelists. And once again, thank you for coming and attending our event today. Appreciate it.